Problem 4, surface plot along with contours. So, let's make a new file, a script, and actually easy surf is probably the easiest one you want, is probably the way you want to go. Easy surf C of, and let's put, let's see, x squared divided by 2 plus 1 minus cosine, and I'm presuming, I think this will do it. This, there is a default domain, so I think the default is 2 pi to 2 pi. But yeah, you can specify. Right. Okay. So I think the way you specify it is, you give it a vector, the x vector, and then the y vector. So what does it say? 0 to pi.
Negative pi to pi for x.
Okay. Negative pi. Let's see. Let's divide it into how many steps. Well, let's just see what. Sometimes it's just okay. Let's just see what happens if I. Does it need a? Is it this format, or does it need a comma? I can't remember exactly how this function works. I'm guessing right now.
You already closed out the function.
I can fix that in a second. Yeah.
The other one is negative 2 to 2. Y is negative 2 to 2.
Okay.
I think you have to have a.
Y is negative 2 to 2?
Yeah.
X is negative pi to pi?
Yeah.
That sounds weird because X, it looks like it ought to be different. Okay. Okay, it likes it, but it doesn't. Oh, there. You get your surface plot and you get your contour.
Can you do it without using easy surf C? Can you do
Yeah, you can.
This is, I know one of my problems I was having though is I was just using surf.
Yeah, let's see, let me get the help function up first. The C's, the contours, you see the contours underneath when you do surf C, mesh C. Mesh is, let's do this with mesh, by the way, show you the difference. Surf gives you the nice colors. Mesh will do the same thing, except it gives you a grid. So now you don't have those colors. The grid is colored, obviously, but you have the white space in between. Surface fills in the white spaces. Mesh just doesn't fill the white spaces. C at the end of the function gives you the contours. You can also do contour all by itself.
What if, so I guess if you were just using surf, it would give just a surface without the contour lines on the bottom?
Yes.
Okay, and if you're using surf, you don't need a step size.
You can specify it, but let's see. Let's go surf.
Just straight surf.
Right.
I want to figure out why mine.
There's surf. No contours. By the way, contours, here's the geology thing with contours. Here's a hill underneath. This is your surface or your mesh. It plots this. Contours just map equal elevations. So the contour map, you can see the matching of how the contour lines match up with the hill. It's kind of nice we're teaching it in the geology lab because we can do it and we can show that. Okay. Now, the
I was using just surf, not easy surf. Make that much difference, but it still should have.
okay.
Well, I keep typing help surf.
Oh, there we go. Surf. let's go. So surf C is the same as surf, except you go. So use the help system. I've forgotten how. I kind of guessed how easy surf worked just from memory, but you can't keep all this stuff in memory. You got to use help sometimes. Sometimes I forgot how surf works, so I'm gonna go find that out.
See, and if you look the X, this second one,
Right,
you have to use X, Y, Z.
right.
And
You have to
and
specify all
and
three.
if you search online for surf, if you actually go to the MathWorks website,
Uh huh.
it says you can have X and Y defined as the domain as X, Y, and Z. And I don't know, it doesn't work to do that.
Let's try it. Let's see if we can do this. Um,
So
so surf C, and we want the contour.
yeah, that should
Um,
work exactly.
X is we can specify X as a vector. What was it? Negative 2 to 2.
Negative pi to pi.
Negative X was negative pi to pi.
Yes.
Oh, not this. Comma Y comma. There we go. And Y was negative 2 to 2. Oops, colon. So you specify one vector for X, a second vector for Y, and then Z we can just put in the function again. Um, let's see. So I can copy, I'm just copying, and all I'm doing is copying and pasting the function into here. Yep, let's get rid of one of them. And I think this will work. Oops. Um, property value pairs expected.
It doesn't have to have a C. No. That the C is just a color, and you specify what color you want it to be. Uh, by default, it's a color based off the Z.
Oops. Step one. Let's see. We want. So if we're specifying X as a vector, we have to have um, several steps. So it's 2 pi over 20. 20.
Yeah, I do like pi over 25.
10. There we go.
That'll get 20
So I'm
steps.
going to define X. I'm going to define Y equals, um, and that's negative 2 colon. Uh,
1/5.
let's see. I'm giving it about 20,
So
a
1/5.
mesh of 20 instead of a mesh of 100. So a mesh of 20 would be, if I go 2/10, that'll give me a mesh of 20. So X is a 1 by 21 double, Y is a 1 by 21 double,
So then
and
you surf C X, comma Y.
right. Let's try that.
You don't have to because it should. I, like you shouldn't have to, but I can't make it work if I don't know
Okay, property value pairs expected. Okay, we're gonna have to dig into the details to use. You saw how it worked with easy. If you can use easy, obviously use it. You saw how it worked with
Yeah, I
easy
just
search.
it
Depends on the problem. They might. Does this one tell you?
just says create a service plot function.
Create it so you can you notice they're showing you easy plot, they're showing you easy contour, they're showing you easy polar. Yes, you can use easy surf. If you have to use surf itself, it's the devil's in the details. I'll have to do a little research on that. I don't have it right on the top of my head. So this is where you got to use the help system and look things up and things like that. Okay. So I'm going to move on. I'm not going to. Yeah,
Okay.
we'll move on from there. I wanted to be sure and show you while loops. So we've done if. The other day we did if statements. The other day we did for. So I want to get up to the while stuff. Um, And, oops, come on, there's mine. Chapter 4. There we go. Select the folder. Come on. Why are you empty? Do not open this. It shouldn't have been. Okay, and I'm sorry. It's up here. I didn't move it. I didn't move it into my folder. Okay, so I'm cool. Everything's cool. Okay, we did the if stuff. I created a function, test, a test function, test if. Let's go see that function. So we just got done with the ifs the other day. So I'm going to put a number input to the function. If it's less than 5, you get this. If it's greater than 5, you get this. I'll show you keyboard, pause, all that stuff too. I might as well input. There's a few other things in this function that are useful to show. So let's go ahead and use this function. Right now, the function is set with a pause in the middle of it. I'll show you the actions of the other things. So if x is less than 5, the function out is going to be true. If x is greater than oops, I wanted to make it. Yeah, let's make it greater. I'll show that in a minute. Okay. So x is greater than or equal to 5, and x is less. So if it's between 5 and 10, it's fuzzy. Else, everything else. I mentioned, here's the else if that we showed the other day. This is else. If it's, basically, if it's greater than or equal to 10, you're going to get into the else. So you could use else if x is greater than or equal to 10, or else. Else just captures everything else. Any other condition, it just captures it. And then the end. Okay, let's save this function away. We'll modify the function a little later, and there we go. TST if, oops, test if of 4. It should say true. And make, so test if 5 should say fuzzy. Test if 6 should say fuzzy still. Test if 10 greater than, so greater between 5 and greater than and equal, oops, something. 10 lost it.
It wasn't less than or equal.
Paused it. You'll notice down here, you might not be able to see it, but it says pause. So pause is a way to let you debug that, okay, I don't know exactly why things aren't working right. Let's put a pause in there. Now I can.
The domain is greater than or equal to 5, but 2 10s are not equal to 10.
Let's go take a look at the script again. Let's go look at the function. There it is. So this time, I put 10 in there. It's not less than 5. It's not less than 10. It is equal to 10. So it's going to hit the else. And in the else, I have this pause. The other branches, here and here, I don't have a pause. Here, I do have the pause. So I'm showing you how pause works. So this part here is pretty much the same as everything else, except it's got some other things going on. So the first thing you're going to encounter is the pause. Second thing you're going to encounter, so we've just shown how pause works. Now, after we get out of pause, we're going to hit something else. It's going to ask for an input. I could comment. By the way, when you're debugging code, if you comment things out sometimes, yeah, you can comment it in. For debugging. You can try to figure things out for debugging. So since we'll do that in a minute. Right now, we'll run it the way it's shown now. So we're right here, right now. It's going to hit this. It's going to ask you for an input. So this is a way for you, in the middle of a function, to enter data by hand. There's also something called input DLG. Very useful. It pops up a dialog box. It's GUI. It's GUI light, if you will. So you can do a little GUI thing. This is strictly command line. But input DLG is a neat little function. It takes a little more to use it. You can do a little more complicated things with this function. This is kind of a simple function here. Input DLG is a little more complicated, but you can do a little bit more with it. It's still pretty easy. Okay. Right, you can set your outputs, you can capture the outputs and use it in your program with input DLG. So it gives you a pop-up window, you enter the data you need to, and then you can keep going. Right now, I'm not even going to show you how to use input DLG. We'll stick with the simple one for now. So I'm at pause. I press any key. It continues. It comes to the input statement now. Now we're here. Now I can change it. It's going to do a couple things. Let's put it to 5. So input inside the function, it ought to say true. You'll get a couple things. Answer. So it outputs this, and y. Now I input 5 here. I should get. Oh, it's fuzzy. It's fuzzy. Right. It came out fuzzy. By the way, you'll notice I put a semicolon. If I didn't put the semicolon, I'd get, it would say fuzzy twice, essentially. Answer equals fuzzy, and then answer equals fuzzy. Okay. Or y equals fuzzy, and then answer equals fuzzy. It would do it twice. Okay. So let's comment this out and see what happens when I do that. Oops. Do the same thing over. And it pauses again. It does pause like before. This time, since I commented out the inputs, it just outputs false. Let's comment out the pause. And let's comment in keyboard. Keyboard works a little bit the same way. There we go. There we go. Now, keyboard. It's K. Yeah, K. It's waiting for an input, so you can go check what X is or whatever anything else is. You can go check and see what it is. It's another command to help, mostly to help you debug your program. When you're here, you can go see what the values of variables are, for example, inside your function. So pause and keyboard they're used for similar purposes. You stop things a while, you take a look at how to see if your program is doing what you expect, and then you can continue. Pause, you just hit any key to continue. Keyboard, you got to hit return to continue. R-E-T-U-R-N. And it stops. Let's try it. So if I tap X, it just stays there. Yeah, it just, well, it tells you what the value is, obviously. If I type Y, it just doesn't do error. You type other keys, you're stuck at that step until you type return.
And it returns it back to.
It just gives control back to the function and continues running.
Does it go past the pause, I guess?
No, nope. It does. We're here. We are right here, right now. I already took pause out, so we're not pausing now. We're using this command. We're not pausing. Okay, so these are a couple things to help you debug. I wanted to show that so you can see what's going on. K, you hit return, and it just returns control. It just starts executing from here on out and finishes up the function. Okay, so that's how if works. There's a couple more. There's while and there's switch. Let's go to switch first. I can't remember. Uh, so let's see. Oh, switch. Switch and if work a lot the same way. Let's go switch. Um, so you get an input. You have X. You can implement switch with an if statement. You can say if X equals 4, if X, else if X equals 5, else if X equals 6. Instead of switching, you can totally do otherwise be like else in the if statement, and then you end the switch. The usefulness of switch is that you it's faster computationally. If statements run a little slower. Switch was developed first in the computer industry because it's fast, very fast. If is a little slower. You have more testing. You have double numbers. Things like that. So if runs a little slower computationally. Switch runs a little quicker. With modern computers, you won't see a difference, right? If you're punching cards, it might make a difference. With modern computers, you shouldn't. So here's switch 4, 5, and 6. We'll test this switch file. Okay, test switch ITCH of. Now, if I give 3, it's going to go into otherwise. It's going to say unknown. If I give it a 4, it should say true. If I give it a 5, it should say fuzzy. Case 5 is fuzzy.
I got a quick question. Instead of 4, if you put in um, like a word, a text, like if you put instead of 4, you put false.
Taco.
Or what about like a vector? Well, no, not like that, but like text, like
That is
text. You just did.
I just did text. I just did text. I'm going to do it right now. Okay. Unknown.
What if you put in like a range or something like that
Oh yeah.
as a case, like if it landed anywhere?
First of all, put in a decimal.
Oh, it doesn't use decimals.
So I'm sure a
Oops.
range would be
So it's equal to
unknown if it
or?
worked.
I think if you put a range, it would give you the different answers. It would probably give you unknown, 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 true, unknown, unknown.
That makes sense.
Let's do this. Let's try this. I'll give it 0 to 10.
It's going to give you some unknown, some fuzzy.
Doesn't work at all.
Must be a scalar range or something.
Right.
Yeah. It's only.
Only works for scalars.
Yeah.
Did the if work with the?
I'm pretty sure the if will not work with the. Let's check what the if function is looking like right now. We have it. Oh, okay. Let's comment out the keyboard. Let's just run it standard.
No wonder you love to test it.
Okay. F. Where's the if statement? Get back to my if. There we go. If.
Do 1 to 10.
Oh, but yeah, 0 to 10.
It's good.
Feel bad now.
No, don't think no.
Doesn't work. Looks like it. You got to convert it. You got to be able to have a logical.
So you can't do it like on a
Logical scalar. Right.
I was saying you can't do it like on value to value. I forget what it's called. Like the dot, like period works.
Right.
You can't do it like that.
If you set A equal to the
Yes.
range, and then you multiply times the dot product of it,
If you can set one matrix to another, you can ask if one matrix equals another matrix, etc. You can do that, or not equal the other matrix. You can do stuff like that. The only thing is
Because yours
this
is
expression, these expressions right here, they have to evaluate to a logical scalar. logical scalar. So x if this was a matrix here, x could be a matrix or a vector, or you could dot products, things like that. It's just that when you go to the logical, you got to get to a logical scalar. So it's got to evaluate to a logical scalar. Okay. Okay, so that's that switch. Let's get to the, unless there's any questions, I'll get to the while. Oops, let's see, go to the editor first. There is a while, which is while, now, you can implement a switch with if. So switch really isn't needed. While, though, the for loop goes through a set number of times. It executes the same commands a very specific number of times. While, though, can be indefinite. You exit on a certain condition. For example, if you're making an approximation to a function, you can exit when the difference between two approximations is very small. For example, so you might go through the loop 7 times. You might go through the loop 100 times.
It's kind of like doing a limit almost, kind of.
Kind of, yeah, a summation. Like if
Like, what is it when you're
let's go to the while.
estimate the value of a point on a range?
Yes.
So this uses the while function.
Tangent line.
I get it. I get it. Yeah.
This uses the while function to do the same thing that we did before with the for. Let's go back to the for. Just showing how to implement it with both a for and a while. Oops. There we go. There's the for. There's the while. So the difference is for my index equals 1 to maximum number, while you got to set it before you get into the while.
Wait, where did the 4 go to?
Okay. This is the while. This is the for. So right here is a difference between the while and for. Right here with the my I equals 0. That's a difference. It doesn't exist in the for. It does exist in the while. So you've got to define your variable before you go into the loop. And you're going to say, while this is less than the maximum number, then you're going to sum the squares. Okay? So it's going to add 1 to whatever the index value is, and then it's going to do the sum of squares. I'll show a couple different things how. Anyway, okay. Let's go. Let's execute it. Okay. Come on, we're. There. So I run in. I'll just run this section. There we go. So I run the section, and for
Until my eye was 5.
my I was 5. Let's see, was that a 5? There we go. Yeah, sum square while my I until my I equals 5. So before it starts, they're both 0. First time through this, second time through this, and so forth. It keeps going.
So the first time through would be like 0 plus 1.
Um, As yeah, first time through, the output set to 1. The second time through, it's 1 plus 2 squared. You're summing the squares. Third time through, it's 1 plus 3 squared. 5 plus 9 is 14, and so forth. So, oops.
This one works out nicely because it's a you only added 1. If you had like 1.5, and it wouldn't have ever made it to 5, it would have just gone past 5. Would it just revert back to
Let's go see it.
like,
I mean, this is where we can experiment.
yeah. Because then it'll go to
Um,
it'll go to 2 point my eye will go to 2 point or 1.5 and 3 and 4.5.
okay. Oops. I didn't. Oh, I know. I went to the section and ran it. There we go. Okay. Same section. We're in the same section, so we'll go ahead and run it now. So now instead of adding 1 to it each time, we're going to add 1.5. It should end as soon as it gets bigger. This will go.
It'll only go to the 4.5.
It'll go 0, 1.5, 3, 4.5, and then it should stop when it gets to 6.
Where'd you get the point fives from? How does it?
It's just we're just showing how this thing works.
Because the other one it ended it
Okay.
back to 5. It actually equaled 5 at a point.
Yeah.
I'm saying
So
it's not ever going to equal 5.
before it starts, the first time through, the second time through, the third time through. So we're adding 1.5 each time, and then the fourth time through, and then you're not going to do a fifth time through because now you're at 6.
Where did you change it to 1.5?
On the my equals my I plus 1.5.
Instead of 0, it'll.
There. Instead of 1, I increased this to 1.5.
Gotcha.
Okay. Now, let's do something even a little different. Let's go back to 1. And a temporary variable equals FO out, while
What's the foul again?
it's just the output variable. It's just what I chose to be the output. Function out, F out.
Then why do you put function out as 0?
Because you got to initialize it. It starts at 0. Because it's not, if I don't start it here, it's not defined here. Okay. So now we're going to do something a little different. While um, while the difference between the old value and the new value is less than, so now this is going to be on a condition. In fact, you could put your condition here. So when the difference between the old and new is less than 100, keep going. But as soon as it gets greater than 100, stop. So it'll go until 10. It should go to 10 loops because when the difference is 10, it's gonna my I squared is 100.
It should be like going the same. You said.
It should go from
This is basically the same thing as taking out the 10.
1 to 10. Right. Right. So it's stopping on but the point is it's stopping on a condition. It's not. I'm not setting the number of times it goes through. I'm setting the condition when to stop. And I have to define temp up here.
Oh, you defined it down there.
No, it's
Equal to 0?
and I gotta watch out.
Did you just have it?
I put it at 0 because when it gets to 10, so it'd be 0 plus 100.
Yeah.
Well,
I'm gonna.
You already defined temp as F out.
Right. So when F out starts at 0, so 0 is less than.
You can't do.
Oh, I can make it 0. Temp plus 100 would be 100. Yeah.
What?
I can set them both to 0.
In the while box. In the box. It's called the box, right? Yeah.
The black box.
Block.
In the block. Yeah. You already have temp at as that out.
Well, you're initializing it. The first is not defined right here. Unless I do this, it's not defined. Right. In fact, let's run it where temp is not defined. Let's see. Oops. Yeah, I went. I think I'm just going to copy this to the command window so I can run it several times. Okay. And max number I shouldn't even need max number. Where's my function again? I shouldn't even, it's not even using this anymore. The input's not used. In fact, it's telling me the input argument max num might be unused. I'm not even using it. It's stopping on a condition. I could do this. Well, I'll just leave it unused. Okay.
100 could be max num.
Right. I'll just leave it unused for now. So, 5 doesn't make a difference. You can put any number you want in there. Now, temp is not defined. It won't let me run it because it's not defined. As soon as I comment it back in, it should run just fine. So it says, when it gets to here, it's going to say, this doesn't exist. Let's see, line 6. Line 6, it doesn't exist. So I need to comment, I need to initialize my variables before I get into the loop. The for loop, when you set my I equals some vector, it initializes right when you do the for in the for loop. Right, it does it. It does the initialization for you. In this case, you have to pay attention. Okay, let's go ahead and run this one. And now it should work just fine. Yeah, it goes up to 10.
So what if you didn't have them equal to each other when you initialized it? If they equal each other in the
Doesn't matter.
block.
That's what I was saying.
So I could start it with, start this with 50, for example.
Yeah, like I was saying, it has to be true.
There.
Gets the same answer.
Same answer. Yeah.
We're good now.
Good deal. Okay.
I think the.
Yeah. Yeah.
What is it again?
What
What
is
is
it?
it? The temp? I think temp just needs to have a number in it to like.
Any, well, if it's,
You get the same answer.
but
Same output.
let's do this. Oh,
It's the same
let's
answer.
see.
They say the same 385.
F out. Oh, I
It
know.
doesn't matter up there, does it?
Yeah, it will. Let's. I'm making sure that temp plus 100 is greater than F out, or F out is going to be greater than temp plus 100 in this case. So I add 100 to this number, and it's going to be less than this number. So now it shouldn't even execute. Shouldn't do anything. Oops, it did do something. Why did it do that? Okay, this is where debugging comes in. Things don't always go as you expect. Or did I forget to save it? That's something that's very common. Oh, I forgot to save it. Take a look. I got to save now. Now it doesn't work. It doesn't do it because when I actually saved it, then we got what we expected. So that gives you a hint, a reminder. If something isn't working right, make sure you save your revisions. Okay, if you guys would, we should be set with the licenses. If you guys would help us by turning off the computers and putting back in the boxes. And if you can help us with that. And Pertl, the licenses should all be fine now. You should be able to work with Pertl.
Henry, look at your test grid and tell us all what you made. Henry, why are you running such a bad mood this morning?
Okay. Just I'll let you know that things are okay.
Boy, this is such a hassle. What in the?
Well, I wanted to go and change a data on one of them, and he got nuts about it.
Oh,
They last so awesome every Friday.
every last one.
This last
Okay.
Friday, you know what it was?
HDTV.
Oh, that was the Friday before last. Was it
Um,
HDTV?
In fact, there was a little card that they had to swap out
That's what wanted that, obviously.
the naming on this.
But last week it was a trip to the
um,
Gaylord.
these guys have to do homework, so if Pertl wrapped up
Gaylord in
ASAP.
Nashville.
Thank you, Brian.
You ever been to next week?
I didn't know.
Do you have a preference as to times?
Well, I went on the online thing and I was gonna do it Saturday just to,
Well,
Dallas is huge.
if you come in as a maker, if you're going to be working TJ shops, in other words, you wouldn't sign
Yeah,
up as a
that's
regular
not, that's
volunteer.
not, yeah, that's not
If
another
you
one they
sign
did.
up as a
Isn't
regular
that
volunteer,
river
then
going
you
through?
really wouldn't be available for the TJC
They did
booth.
a nice
So I'm
skating
trying to
rink
collect
and ice
TJC names.
slides.
On the river?
okay, so what time's
No, they
at
turned the
ice?
whole thing to
Um,
ice.
see,
Yeah, my
Jordan,
sister was that into it.
I think is going to go early, so
I've been
mid or
skating
late.
on Bloomington Cat in Dallas
Mid.
so many times.
Okay,
It's a great place.
so
See you later, Dan.
let's go at let's have you do show up at 11.
11.
We'll go 11 to 2,
Alright.
and um, should be able to let you go for the Epi Bird show.
Okay. Thank you.
Okay.
Can I snag your test, sir?
Yes, you may.
Oh, you got a straggler right here. Like guilty.
They obviously they had a big
Yeah, what were
hassle.
they doing back there? They were
Oh, it's all that licensed stuff that